Myself, Umashankar, you can call me as a Uma, and my team member Uttam. So we both have been working in this Postgres. And by seeing me, you can think that I'm very senior, but I'm very junior in Postgres. So I'm just 4 years in Postgres, just learning still. I'm more on Oracle side, but getting transition to Postgres. So as you know, Postgres is mentioned, it's a open source, and it has been robust setup, and it has been growing in huge nowadays. So that's the reason now Postgres is very important for us. So let's get into the topic. Okay. So this is a high level agenda. We'll just go with what is Postgres HA, then HA architecture, and to setting up the HA architecture, we need the Patroni, etcd, HA proxy, and one more keep alive is there. These are the main components which we needed when we are going to set up the HA cluster. Then backup and recovery, just high level methods we are going to say. It's not going to in depth, just as a important way we are going to say. Then load balancing and end monitoring. Then how the Patroni helps us the HA cluster to have the automated failover, and in etcd is helps the select the best leader, the primary and secondary, that is used in the quorum method. And finally just a short notes on the best practices on the having the production HA setup. Okay, so here just I want to give high availability. See, basically in any production system, high availability becomes a major concern. So the downtime becomes a major problem if the system is not available in production. So that's the reason most of the systems companies go for the HA, so that even if any one database or any one node is down, another is always availability. So the application end users sees that there is a no downtime, my application database is running. And especially as a DBA, you have to ensure that your DB is always 100% up. So that's the reason that HA Postgres HA setup we have to do. So that's a line setup we are mentioning here. Minimize the downtime, ensure the service continuity, data loss, and application performance. So this is high level. And as I mentioned in my previous slide, you can see the Postgres SQL cluster is used. Patroni, which is just an orchestration tool which manages the failover and fallback in the Patroni in Postgres setup. And etcd cluster, which is a cluster. etcd is just information where etcd, I think many of you would have worked in Unix, means you can see there is a directory called /etc. So there you can store the key values for the etcd directory. That's a short form, they use it in etcd directory cluster, where it clearly shows where the primary, secondary, all this information it stores in the etcd information. And finally here we have used the HA proxy, that is used for the load balancing from the application team. Whenever anyone connects, it reroutes and it will be easily for following it up. So that's about the HA proxy. And these are the key terms. Still the list goes very big, but when you are entering into any HA concepts, these keywords you should be getting familiarized. So I'm not going to go through in each step, but I just give the primary server. Many of them, any would have worked in this HA availability. These are very common terminologies used in the HA system. The primary server, standby, and when it comes to the replication, when the primary and the secondary or the third node or anything, we have to have that val. The val is nothing but write ALN logging, and in this shows the stores the complete transactions data. So val archiving, that streaming replication means on the fly you get the data is getting transferred. Then replication slots, then physical replication, and physical replication is nothing but a block level replication. So the block level it gets copied from the primary to the secondary, and logical replication is at data level. Data level in the sense you can select the tables which you want to do the replication, and it seems there are more. We have not done much on the logical replication, but HA replication using the physical we have done extensively. So logical replications has been enhanced in 17.4 and other newer versions. And replication also, we have two types, synchronous and asynchronous replications. And high availability constants also, this is automatic failover. So when the primary is due to some issue, it's getting failed. So automatically the pattern in etc coordinates and it promotes the secondary as a primary. And switchover also manually due to the maintenance activity or any other application or any other thing, you can do a switchover. The promotion is just a word that promoting the converting the standby to primary level, and rewind in the sense recognizing resyncing the old primary to the standby. And split brain is something like when etcd does not able to understand which is the right, so which is the right leader to follow. That is called as a split brain. That is the main thing. And to maintain this, the quorum is very much needed, which is after all number of etcd should be there, so that it's able to correctly select the leader which has to follow. Okay. And maybe Uttam, you can cover it from here also, maybe since you are doing.
Sure. So,
you can go ahead.
yeah. Okay. So, good afternoon, good evening, everyone. So, my name is Uttam. I work for Kindred. So, I have around 18 plus years of experience on Oracle database, and I have around 3 years of experience on Postgres. So, as Uma said, like, yeah, we are still learning. Okay, I would say. So, this is my first presentation. So, kindly bear with me. Okay. So, I'll start with HA availability architecture. Okay. This is a normal, minimal what we require for setting up HA availability. In that, like, we have one primary and two standby nodes and 5 etcd cluster, and you can have 2 HA proxy or 4 HA proxy. So it is why I say like it is 2 or 4 is like if you have 2 different applications which you want to divert, like one for read write and the other for only write operations, then in that case, like, you can go for 4 HA proxy, where one will be, active passive and the other one is active active. Something like I would say like you have 2 applications. One is like Kafka and the other one is any other applications which might require only for read operations. So in that case, like you can just go for load balancing for 4 HA proxies, 2 HA proxies, and 2 are for active passive, which Kafka will only do the write operations. It just to dump the data from other source of database. Okay. And here, as I mentioned, like data cluster. So here we should have one primary node, and that is for read write operations, and 2 standby nodes, which can be, keep as a recovery managed or both recovery managed and for read operations. Okay. And for cluster management, you require a patterning. This is a open source tool where you can configure it for your automatic failover, and it will manage your PostgreSQL. Okay. All the, when there is a service disruption on your primary node, then in that case, this pattern is responsible to do the automatic failover. Now, distributed consensus, it is something like we call it as a etcd. So this has all the information about your, primary and secondary nodes. You will have all the cluster configuration information. Based on this information, configuration information which resides in this etcd, patterning will be able to decide like whether your primary is healthy, or if it is not healthy, then in that case, based on reading out this etcd information, it will fail over to the secondary available node. Now here load balancing is like, as I mentioned, 4 HA proxy instances that it is based on the, configuration, requirement. If suppose, as I said, you have multiple applications where you do not want to, keep all the, all the connections on one single database, like primary, not to increase your load. So distribute your load, like read operations on your standby and read write operations on your primary. So HA proxy is something like where it is also an open source tool. It will just, sends your request based on your algorithm which you defined in your HA proxy configuration. So keep alive is something like a high availability. This is something like configured with can be configured with HA proxy, and this has to be configured using the virtual router redundancy protocol, and it requires a virtual IP. So this virtual IP is something like configured via keep alive, and when there is a service disruptions on HA proxy, so this is responsible to failover all the connections or reroute the connections to the other HA proxy which has been configured. Something like if you have configured like one HA proxy on your DC and the other configuration on your DR. So by any chance, like if you have service disruptions on your DC HA proxy, then in that case, like this keep alive is something like where it is responsible to fail over all the connections for the other HA proxy which is in DR. Now the operating system where you can configure it with RHL or any other OS. Okay, so this is actually high availability architecture and automatic failover and scalable read operations. Now the system requirements and preparation. So these are some of the prerequisite packages which are required for Postgres installation. Okay, and these prerequisites are actually required when you are installing Postgres. Now for package installation, you require PostgreSQL 17.4. Okay, this can be installed via a package, or you can download it as a source code, and you can also install that manually. Okay, and Python 3.9 plus and pip both are required for Pattern installation. As I mentioned, like Pattern is also open source, and etcd is something like a distributed consensus, like it is 3.5.21 is the version, and HA proxy is something like 2.4.22, and keep alive version is like 2.2.8. So these are the package installations which we require to set up the HA. And system configurations is we need some of the ports, like 5432 is the default port, and 2379 is the port which is required for client communication. In order to communicate with Pattern agent or any REST API calls, like 2379 is something like required, and 2380 is for peer-to-peer communication. You will be configuring 5 etcd nodes as a cluster. Let's take an example. So to communicate between the etcd peer nodes, it requires 2380. Now here 5000 is, as I mentioned, this has to be configured in HA proxy. So 5000 is something like for your read-write operations, and 5001 is for your write operations. As I mentioned, like I have an application where I generally generate only the reports. I don't want to do any read-write operations. In that case, you will be configuring 5000 port in your algorithm which you configure in HA proxy. So that algorithm will take care of rerouting the connections based on the read-write or write operations. 8008 is port for a REST API connection. So this can be configured in, these are the firewall rules which are required. And time synchronization, so this is something like the time should actually synchronize between all the nodes where to have a consistency. And host name resolution, like it has to be configured either in etcd or etc host or in your DNS for all the nodes which you are going to configure.
So this version we have taken it as a sample which we have configured,
Okay.
but higher versions has already come. Okay, so don't take this is as a base. You can have it as another versions also, but since we have done it in our setup, so we have just given this version numbers. Okay, so
Okay.
right.
Thank you. So this is something like I would like to show you an architecture where for high availability. Here if you see on top layer we have two connections getting, like one is 5000 which is for read write. So you can make it as I'll take an example of Kafka. Okay, so this Kafka actually writes all the data which can be pulled from other sources like Oracle database or MySQL or any other database. it has to pull, I mean, it will be pulling all the data and it has to dump in PostgreSQL. Okay, and the other connection is like 5001, which is a read-only connection. Okay, now how this connection workflow happens is like if a Kafka connection makes from 5000, it connects to HA proxy, which is in DC here, and the other node for this is like a passive, which is in DR. Okay, and for application you can see like two HA proxies, active, and the load balancing has been configured in DNS. Okay, now when there is a connection happens on your DC, here you are going to write an algorithm saying like to bind it on port 5000. If a connection makes up with a 5000, then it will identify that it has to connect to node 1, which is a primary, which is in DC. And suppose if there is a connection happening from application, it has to bind from 5001, and now what happens is the first connection will go to node 2 and the second connection will go to node 3, which means this happens in a round robin fashion. Now you have another kind of a configuration also where you can make it as a least connection, load balancing as a least connection. So how it works is, suppose like if you have 10 connections on your node 2 and you have only 5 connections on your node 3, then in that case like HA proxy is having an ability to identify that this has a least connections and it will make a connection with your node 3, which is in DR. So this is actually, and this is maintained by like HA proxy algorithm. So while we are defining the algorithm in HA proxy, we are going to define like how we are going to configure load balancing. Either it may be round robin or either it may be least connection, and the other connection type of load balancing is source hash IP, which can be hard coded. Like for example, if you have an IP where it has to connect either node 2 or node 3, so in that case also you can just hard code this. So these are the 3 types of load balancing can happen. Now here you have 3 nodes. So first node is configured with Postgres and Patroni and etcd, and node 2 is configured same as node 1 like Postgres, Patroni and etcd, and node 3 is also configured same with Postgres, Patroni and etcd. Now here you have 2 more extra nodes with etcd. So here like in order to have an automatic failover, you should have a quorum. Majority of etcd nodes should be available up and running. Okay, now you can have 3 etcds here, but the challenge here is, for example, if my DC goes down, entire data center goes down, then in that case there is a failover, there is a service disruption, because majority of etcd nodes are down here. For that purpose, what we have did is like we have actually configured 2 more nodes, node 4 and node 5, which is in DR. If suppose if DC is down, okay, then in that case automatically, as it has 3 etcd nodes up and running where majority quorum is available, then in that case automatic failover can happen. Okay. So this is a component overview. So for Postgres 17.4, so we have like a streaming replication and slot sync, and it has also like a logical replication. This is something like a table level replication. Physical replication is something like copying a block from your primary to standby. Let's take like you have updated a record in your primary. The entire block will be transferred and it will be applied in your standby. So this is a physical replication. Now coming to Patroni, like this has an ability of automatic failover. This has an ability of automatic failover and leader election. Okay, and health monitoring of your nodes and cluster state management. Now coming to etcd, like it is a distributed configuration store for consents, and it has a leader election coordination and stores configuration and cluster state, and it is just ensures quorum based decisions. Like as I mentioned, if majority of etcd nodes are available, then automatic failover can be taken as a decision. Now HA proxy is something like load balancer for a single database point. Health check monitoring and traffic rerouting is something like availability of HA proxy, and read write connection is splitting is for HA proxy. So coming to Pattern cluster management. Now this actually the cluster, it has three categories, I would say. Cluster management is something like it monitors all the node health and automatic detection of failures and coordinate responses across all cluster members. Okay, and automatic failover is something like promotion of your standby if your primary has any service disruptions. Okay, and this is something like it can be completed within 30 seconds. This actually you can configure it in your pattern.yml file. This is something like there is a parameter called TTL in your pattern.yml file. So if you configure that parameter, based on that value, this will be, the automatic failover happens. And you also have one more parameter called loop time, which can be configured so that in that particular time, loop time, it will check the failover thing. Okay, and leader election is something like coordinator ensures a primary at all times. It is to avoid split brain situation. Now etcd will be actually follows raft algorithm. Okay, so this is something like which also leader will be elected based on the TTL, and it actually etcd is a lease mechanism. Okay, so now Patroni is basically, as I mentioned, it's an open source tool, and it can these are the key features of Patroni. Automatic failover and leader election, and configuration management will be done by via DCS. DCS is nothing but etcd. So REST API for monitoring and management, and it supports synchronous and asynchronous replication. I'll speak about a little bit about these two replications in later slides. So, and customizable callbacks for various cluster events, and integration with multiple DCS backends. So why it can be used is it simplifies PostgreSQL HA setup. Normally, this will take care of automatic failover. So there is no manual intervention is not required when there is a service disruption on your primary. So this automatically just communicates with etcd. It reads details from etcd, and it will do the automatic failover, and handles complex failover logic automatically, and active community and regular updates. This is also like a cloud native and container friendly. These are some of the options for Patroni alternatives. So first one is like rep mgr, and we have also stolen, and we have PAF, which is PostgreSQL automatic failover, and we have PG auto failover and PG pool 2. So these are some of the.
The idea behind this is mainly to give you what are the other options. So it is totally depend upon your client request. So there are both pros and cons in each tool. Okay, so you have to do some check on this. Then based on the requirement, you can easily switch over on that.
So this is how replication data flow. Now client applications, whenever there is a request, it will just go to your primary. This will accept all your read write, and now here once this is done, once here it is updated, the change will be transferred to your all the standbys by using wall stream. Now coming to some of the key PostgreSQL parameters to configure synchronous replication. So val level is something like replica is that is actually used for enabling your streaming replication and hot standby. Second thing is like a max wall senders. So here this is something like replication slots. If you are configuring 10, you can configure 10 replicas. Okay. Now generally it is a best practice to keep a higher value. In future, if you have configured 2 standby nodes, and now in future if you want to increase again, then this will be helpful. And val keep size is something 1 GB, where this is pattern val files are managed automatically. It is not something like in Oracle you can manually delete. It happens like automatically. Now what you are telling you with this parameter is like you can keep 1 GB, okay, of val files always in your PG world directory, even though after it has applied your standby. Okay, archive mode is something like on, where this is used to generate your val archives. Hot standby is something you are telling your PostgreSQL to keep in recovery and read only. And synchronous commit is something on, which is required for synchronous replication. Now here synchronous mode strict is false, we kept it. Why? Because this, if you are keeping it as a true, if you have configured your primary and two standbys. In synchronous standby, what happens is like if a change has been, a read-write operation happened on your primary, until it gets acknowledgement from your standbys, both standbys. If you have configured sync nodes, sync standby for both, it will not commit in your primary. So that is a functionality of synchronous standby. What we have configured is we have configured it as a false. Why? Because now what happens if for example, if your both standbys are down, in that case your primary will become automatically async mode, which will not wait for your standbys to get acknowledged. So that is where we have configured it as a false. So this generally, if suppose if there is a major productions, so this is generally recommended.
So here one more point to add is val level is replica, but in 17.4 you can add it as logical also. So that will take care of your both replica and logical replication. The reason why we are mentioning it as replica means it will go for byte level, unnecessarily avoid the overload. That's the reason.
Okay, now etcd distributed configuration store. So these are the key features of etcd. Strong consistency guarantees and distributed consensus via raft algorithm. So raft is something like where it is used for your electing the leader. Watch mechanism for real time updates and high availability with leader elections. Okay, and why we use it is something like for reliable distributed consensus and fast read-write operations and simple HTTP API, industry standards for distributed configuration. So these are some of the etcd alternatives. So console and zookeeper are some of the tools like for etcd alternatives. Now HA proxy and load balancing. So this is something like it is an open source tool, as I mentioned. So this is basically proxy server for both TCP and HTTP applications. Key features of HA proxy is layer 4 TCP and layer 7 HTTP load balancing and health checking with customizable checks, multiple load balancing algorithms. So as I mentioned, like round robin least connection source hash AP, SSL, TLS and termination, and statistics dashboard can be configured with this HA proxy. ACL based routing rules can be configured with HA proxy. And why we use is like industry standard for load balancing, and it is a high performance and low resource usage. So you can configure it with very low resources on a server. Flexible configuration, and it is very excellent for PostgreSQL connection routing. It has an ability to write to primary and reads to your standby. Okay. So this is like a HA proxy configuration where when there is a connection from client, so there is an internal algorithm in HA proxy. When a client connects via 5000 port, it redirects the connection to the primary. When there is a 5001 port connection, then it will sends that request to your standby. Again, it is based on your algorithm. If you want to configure it as a round robin least connection or anything, and these are the key configuration elements. So as a single point and single endpoints for writes and reads for 5000. Backend health checks will be from Pattern API, checks every 2 seconds. And load balancing has 3 types. and timeouts either client or server will be 60 seconds, and connect actually after 5 seconds it gives us a like a failover. And health monitoring, like you can just validate node availability via Patterny API, and it will automatically remove the failed nodes. Read write can be splitted according to the port which you have configured in your HA proxy. Single endpoint, one address for applications. So these are some of the HA proxy alternatives. PG Bouncer, PG Pool 2, and NGINX, Envoy, and Cloud Load Balancers. So these are some phases where we are going to configure HA proxy. In phase 1, we are going to configure etcd cluster setup. So 5 etcd nodes can installed and configured. There is a configuration file, okay, where you have to define all your configuration, and you can start the etcd services, and by using etcd-ctl command, like you can just verify the cluster health. And for a second phase is PostgreSQL installation. Now it is PostgreSQL 17.x repository on all the 3 database nodes, and it can be installed via packages or a source code, and we have to initialize data directory on primary node. And phase 3 is Patterny configuration. So Patterny installation can be done via pip, okay, and we need to create patterny.yml and configure Postgre parameters, start the services. Now HA proxy is something like we can be configured in 4 HA proxies. Configure backend pools and with Patterny health checkpoints. And keep alive is something like this is also open source tool. You can install and configure according to the keep alive configuration. What is it? Okay, so this is how like the output will be visible. Like when there is a this is like first member is your host name and your host name and host IP, role, and the state. If it is like a running, then it will be for primary, and if it is sync standby, it would be showing as a streaming. TL is a timeline, lag is MB, how much lag it is available. So HA proxy routing strategy. So as I mentioned, like 5000 is for read write, and 5001 is for like read only. So these are some Patterny REST APIs for node health check / primary. If it makes a HTTP request, then it gets like primary, then the response will be with 200, same as a replica, and readiness and liveliness.
Due to time, we'll little bit run fast and we'll complete it, so that we can have separate session also.
Okay. So etcd quorum, how it is, like I have configured 5 etcd nodes. If 5 etcd nodes are available, quorum is available, fully operation, risk is none. 4 etcd still available, operational, but risk is low. 3 nodes, like out of which 2 got failed, available, vulnerable cluster status, but risk is high. If we have 2 nodes, available, 3 got failed, quorum is lost, the cluster status will be read only, and risk is critical. Okay. Automatic failover mechanism. So failover detection, failover execution, and these are the post failover things where we can see in automatic failover mechanism. So these are the failover and fallback scenarios. So here primary node crash, standby available, backup needed, no. And primary node crash, no health replica available, yes, you require a backup. Okay.
So the idea behind this, see, some scenarios we need the backup, and some scenarios we don't need the backup. Automatically Patterny will. So that's to have idea. We have just given it at what point we need really the backup, or where automatically through Patterny itself is to try to bring the up.
Same thing. Whatever we explained in etcd quorum.
So here the main point is you have to check whether the database will become into read-only mode. So that is one key point. Even though when its availability is there, so for third stage it will show the DB mode will be, you feel the DB is up, but it will not be in read-write mode. So that is the option we have given it as a DB mode.
Okay. So
I go ahead.
complete it.
Okay, so this is backup and just eye level, as I said, in the backup level. So everyone has to keep recovery is a very important factors. So here we have given the PG dump, and PG is logical, physical backup, and there are various number of backup tools are there. But I is Verman and PG backrest seems to be a very good, and PG backrest has now more with the cloud backup solution also. Okay, so these are the high level best practices. The list is very big, but these are the critical things, the monitoring and the failover testing is very important, and backup strategy, at least quarterly or halfly, it's very much mandatory to test the recovery process. Okay, so overall on this summary, we are whatever you've done is automatic failover, zero data loss, distribution, application, all these things have been done with HA proxy using the Postgres, whatever we have etcd, Postgres, and HA proxy and keep alive. So with that, this is the summary what we have done in HA setup in our thing. Okay, so that's from our end.
We have time for a couple of questions to Uma and Uttam if somebody wants to.
So feel free, because as I said, we are also in learning phase. It's so open. If you get more questions, also we can learn, or you can have connectivity with the networking. I think already Arya said that during say networking sessions we can have. So feel free to ask the questions, even if I'm not able to answer. I can update it to you. So that will be really useful, because as this is the best activities, the networking, the meetup is more and more you do the networking with team members, you'll get a really enrich of knowledge. That is the best way. Discuss with team and that shares the knowledge. It's already written there. Learn and connect. Exactly. Okay.
Thank you so much.
Thanks.
Thank you.
Thanks.
Thank you.